here we have butane reacts with oxygen gas to produce carbon dioxide and water. It looks pretty daunting, but it's doable. On the right hand side, we have one carbon and we have a total of 3 oxygen, but let's break it up to make it easier to balance. So we have 2 oxygen as part of carbon dioxide, followed by 1 oxygen as part of water, to get us a total of 3 oxygen on the right hand side. And as for the hydrogen, we have 2 hydrogen on the right. On the left, we have 1, 2, 3, 4 carbon, and we have a total of 2 oxygen on the left. And as for the hydrogen, we have 2 plus 3. We have 3 plus 2 plus 2 plus 3. That gives us a total of 10. Let's start by trying to balance out the carbons first. So on the left we have 4, and then on the right we have 1. Least common multiple of 1 and 4 is 4. So let's make the coefficient in front of carbon dioxide to be 4. With a coefficient of 4, we have 4 carbon on the right and 8 carbon and 8 oxygen as part of carbon dioxide on the right hand side. So total, now instead of having 3 oxygen, we have a total of 9 oxygen on the right. So we've balanced the carbons. It's left with the oxygen and the hydrogen to balance. Of the two, the hydrogen looks a little bit easier to balance, so let's do that one first. Least common multiple of 10 and 2 is 10, so we need to introduce a coefficient of 5 in front of the water. So now we have 10 hydrogen on the right and 5 oxygen as part of the water. So total we have 13 oxygen on the right. So we've balanced the carbon and we've balanced the hydrogen. Now the issue is the oxygen. For the sake of balancing the equation, we are going to have to multiply the 2 oxygen on the left hand side by 13 over 2. That way we can have 13 on the left and 13 oxygen on the right. However, keep in mind that we cannot have coefficients be fractions. They need to be whole numbers. So although our equation is technically balanced, it can't stay like this for it to be correct. So what we have to do is we need to get rid of this fractional coefficient by multiplying this whole left hand side of the equation by 2. So now we have 2 in front of the butane and 13 in front of the oxygen. So total we have 8 carbons on the left, 20 hydrogen on the left, and now we have 26 oxygen on the left. And it's an equation, so what you do to one side, you have to do to another. Because we multiplied the whole left side by 2, we have to do the same to the right hand side. So now instead of a coefficient of 4 in front of the carbon dioxide, we have a coefficient of 8, and then instead of a coefficient of 5, we end up having a coefficient of 10 in front of the water. And so now our equation is balanced. We have a decane, which is C10 H22 reacts with oxygen gas, O2, to produce CO2 and water, H2O. On the left hand side we have 10 carbons, 22 hydrogen, and 2 oxygen. On the right hand side we have 1 carbon, total of 3 oxygen, but we'll break it up to make it easier to balance. So 2 oxygen followed by 1 oxygen, and then we have 2 hydrogen. Let's start by trying to balance the carbon. Least common multiple of 10 and 1 is 10, so let's introduce a coefficient of 10 in front of our carbon dioxide. So now we have 10 carbon on the right, and we have 20 oxygen plus 1, making it 21 total oxygen on the right. Let's go ahead and try to balance the hydrogen next. We have 22 on the left, 2 on the right. Least common multiple of the 2 is 22. So we need to multiply the water by a coefficient of 11. So now we have 22 hydrogen on the right, and a total of 31 oxygen on the right. We've balanced the carbon, we've balanced the hydrogen. Now the oxygen is what we need to balance. There's 2 oxygen on the left and 31 total on the right. So for the sake of balancing this equation, we need to multiply the oxygen on the left by a fraction of 31 over 2. That way the oxygen can be 31 on both sides. So our coefficient in front of the oxygen is going to be 31 over 2. And remember, our coefficient cannot be a fraction, so we need to multiply this whole left side of the equation by 2. And since it's an equation, what you do to the left, you also have to do to the right. So we're going to multiply both sides by 2. 2 in front of our decane, 31. And then for the right side, we'll have 20 in front of our carbon dioxide, and 22 in front of our water. And that's it. Here's the combustion of propane. C3 H8 propane reacts with oxygen to produce carbon dioxide and water. On the left, we have 3 carbon. On the right, 1. On the left, we have 8 hydrogen. On the right, we have 2. And then on the left, we have 2 oxygen. And on the right, a total of 3 oxygen. 2 oxygen on the right, followed by 1 oxygen, making a total of 3. Let's balance the carbon first. Least common multiple of 3 and 1 is 3, so let's introduce a coefficient of 3 in front of the carbon dioxide, and we now have 3 carbon on the right and now we have 6 oxygen as part of the carbon dioxide, so a total of 7 oxygen. Now let's go on to balance the hydrogen. We have 8 on the left and 2 on the right, so least common multiple of 8 and 2 is 8. So let's introduce a coefficient of 4 in front of the water. So now we have 8 hydrogen on the right and an additional, instead of 1 oxygen, we have 4 oxygen as part of water. So a total of 10 oxygen on the right. So the only thing left now to balance is the oxygen. Least common multiple of 2 and 10 is 10, so a coefficient of 5 in front of the oxygen on the left hand side is going to balance this equation. Here's the combustion of ethane. You have C2, H6, which is ethane, reacts with oxygen to produce CO2 and H2O. On the left, we have 2 carbons. On the right, we have 1. On the left, we have 6 hydrogen. On the right, we have 2. And then on the left, we have 2 oxygen. On the right, we have a total of 3 oxygen. Least common multiple of 2 and 1 is 2, so let's introduce a coefficient of 2 in front of the CO2. And so now we have 2 carbon on the right and a total now of 5 oxygen on the right. Moving on to the hydrogen, we have 6 on the left, 2 on the right. Least common multiple of 2 and 6 is 6, so we need a coefficient of 3 in front of the water. And so now we have 6 hydrogen on the right and a total of 7 oxygen on the right. So we've balanced the carbon and we've balanced the hydrogen. Now, as for the oxygen, for the sake of balancing the equation, we need to multiply the oxygen on the left hand side by a fraction of 7 over 2. That way we can have 7 oxygen on each side. But again, the coefficient cannot be kept in the form of a fraction, so we're going to have to multiply the left side of this equation by 2 to get rid of that fraction. And remember, it's an equation, so what you do to one side you have to do you have to do to the other. So we're going to multiply the other side by 2 as well. We're going to have 2 in front of the ethane, 7 in front of the oxygen, and for the right hand side we're going to have 4 in front of the carbon dioxide and 6 in front of the oxygen. And so now our equation is balanced. C6H6 benzene reacts with oxygen to produce CO2 and water. On the left hand side we have 6 carbon, 6 hydrogen, and 2 oxygen. On the right hand side we have 1 carbon, 2 hydrogen, and a total of 3 oxygen. Let's balance the carbon first. Least common multiple of 6 and 1 is 6. So coefficient of 6 in front of the carbon dioxide. So now we have 6 carbon on the right, followed by a total now of 13 oxygen on the right. Moving on to balance the hydrogen, we have 6 on the left, 2 on the right. Least common multiple of 6 and 2 is 6. So we need a coefficient of 3 in front of the water. And so now we have 6 hydrogen on the right and a total of 15 oxygen on the right. And for the sake of balancing the oxygen, we're going to have to multiply the 2 oxygens on the left by a fraction of 15 over 2, so that we have 15 oxygen on the left and 15 oxygen on the right. So our coefficient in front of the oxygen is going to be 15 over 2, but we can't keep our coefficient as a fraction, so we need to multiply this whole left side of the equation by 2. And remember, it's an equation, so what you do to one side, you have to do to the other. So we're going to multiply the other side by 2 as well. Now we just need to adjust our coefficient. We'll have 2 in front of the benzene and 15 in front of the oxygen. And as for the right hand side, we're going to have 12 in front of the carbon dioxide and 6 in front of the water. Now our equation is balanced. In this equation, we have iron disulfide reacts with oxygen gas to produce iron oxide and sulfur dioxide. On the left hand side, we have 1 iron, 2 sulfur, and 2 oxygen. On the right hand side we have 2 iron, 1 sulfur, and a total of 5 oxygen. But let's separate the oxygen. So we have 3 oxygen followed by 2 oxygen to give us a total of 5. Let's start by balancing the iron first. Least common multiple of 1 and 2 is 2, so we need a coefficient of 2 in front of the iron disulfide. So now we have 2 iron on the left and 4 sulfur on the left. We've balanced the iron. Now let's go ahead and balance the sulfur. We have 4 sulfur on the left, 1 on the right. Least common multiple of the 2 is 4, so we need a coefficient of 4 in front of the sulfur dioxide. So now we have 4 sulfur on the right and a total now of 11. Oxygen on the right. So the iron is balanced, sulfur is balanced. Now we need to balance the oxygen. For the sake of balancing the equation, we are going to multiply the oxygen on the left hand side by the fraction of 11 over 2. That way we have 11 oxygen on the left and 11 oxygen on the right. So our coefficient in front of the oxygen is going to be 11 over 2. However, we cannot have our coefficient be a fraction, so we need to multiply this whole left side by 2. And since it's an equation, what you do to one side, you have to do to the other. So we're going to multiply the whole of the right side by 2 as well. So now, let's adjust our coefficients. We're going to have a coefficient of 4 in front of our iron disulfide, a coefficient of 11 in front of the oxygen, a coefficient of 2 in front of the iron oxide, and a coefficient of 8 in front of the sulfur dioxide. Now our equation is balanced.